We will go through few examples on Z transform. Let us say we have to find Z transform of the following signals. I'll take the first signal, x of n equal to a raised to n u of n. So this is one signal for which we have to find out the Z transform. I can use the definition of Z transform to find the transform. So which is summation x of n z raised to minus n, where n varies from minus infinity to plus infinity. X of n given in the question is a raised to n u of n into z raised to minus n. Now u of n, we all know that it's a unit step sequence. It is equal to 1 only for n greater than equal to 0, and it is 0 for n less than 0, and hence because it is 0 for n less than 0, the lower limit of the summation will change to 0 to infinity. U of n will be 1 in that range, so it will be just a raised to n into z raised to minus n. This can further be written as a z inverse raised to n. This is nothing but geometric progression series, for which we have this standard formula which says that this will be equal to nothing but 1 upon 1 minus the common ratio, which is a z inverse, and this can further be written as z upon z minus a. But I can apply this series only on the condition that mod a z inverse is less than 1. Otherwise the series will not be summable. It will not result into a finite value. So this is a condition that mod a z inverse should be less than 1. And further this condition will become, I'll take this z inverse on the right hand side, so it becomes mod a less than mod z, and in simple words it will be mod z greater than mod a. So the Z transform that we have just now calculated is not valid for all the values of Z. It is valid only for those values of Z for which mod Z is greater than mod A, where A will be nothing but this constant which was given in the question. We are only concerned with the magnitudes here and not the actual values, and this gives us what is very famously known as ROC, region of convergence. So what is ROC? ROC is nothing but the range of values of Z for which the Z transform will exist. For the remaining values of Z, this Z transform will not be valid. The Z transform will not be defined in simple words. So it's very important to mention ROC along with any Z transform. So if I quickly plot the ROC of the given function that we have just now got. So mod z greater than mod a, so I'll first draw the circle of radius mod a. So let's say this is the circle with the radius equal to mod a, and mod z greater than mod a will be nothing but the region which is exterior to this circle. So this whole thing will be nothing but the ROC. Please remember the horizontal axis is called real axis and the vertical axis is called imaginary axis. That is because Z is a complex variable. It's called complex Z plane. So this two-dimensional plane is nothing but a Z plane. So what is the region of convergence for this function that we have just now got? It is exterior to this circle with radius mod A. Similarly, let us take up one more similar example. The second example that we are taking is x of n equal to minus a raised to n u of minus n minus 1. Alright, so let's find its Z transform. I'll use the definition again, which goes something like this: summation n equal to minus infinity to infinity. X of n, I'll substitute it directly this time, u of minus n minus 1 into z raised to minus n. Now we will have to understand what is u of minus n minus 1, so as per which we can modify the limits. So we should quickly recall the operations of folding, shifting, etc., which you must have again studied in the course of signals and system.